Okay, Shar, you're good to go.
Thanks. Perfect. Welcome everyone to the Identity Special Interest Group for January 9th, 2025, our first meeting of the year. Thanks for joining us today. Today we'll go over some quick working group status updates and then hear a presentation from Daniel Fett on digital credentials query language in OpenID for VP. So really looking forward to that. Since this is a Linux Foundation call, we are following the antitrust policy and we are following the code of conduct as well, linked here. We're recording the call and it'll be posted on the meeting page later today for those who are watching the recording. Um, let's see. Are there any announcements before we jump into our agenda? All right. Let's see. I'll go through these working group status updates pretty quickly so that we have plenty of time for the presentation, but do feel free to stop me if you have any updates of your own that you would like to jump in with. So let's see, we'll start with the Open Wallet Foundation, starting with Aries Cloud Agent Python. Release 1.1.2 RC0 is out, and 1.1.2 is ready. There will be a new LTS version that'll be 1.1. We also talked about did registration and did plugins for checked, and the one for did web VH is pending. And then we discussed did web VH and witnesses. In Credo, they've been working on message pickup and mediation approaches, finalizing their annual report. I know that got accepted, and they received a unique ID demo. Let's see, on Bifold, they've been working on the transition to OWS and discussing a dependency injection. In OWL, let's see, they've got their first meeting of the year next week. Wasn't able to find more recent meeting notes from them. In the wallet interop SIG in our meeting yesterday, we talked about digital trust in 2025 goals and trends that people have noticed. So we talked specifically about the question of synchronization across wallets and devices, and the different considerations with solutions, independent testing and certification, did web VH adoption, verifier verification or verifier identification, verifying the verifier, whatever we want to call it. Let's see. And then, Sean, did you
Yeah.
want to jump in on those?
Absolutely. Thanks, Shar. I can keep this really quick. Wanted to welcome three new projects to the OWF, which were approved by the Technical Advisory Council yesterday on January 8th. That link takes you to the recording for yesterday's TAC call. Digital Credentials Query Language, which we're going to talk about today. And I finally get to meet Daniel Fett in person instead of trading 1,000 emails between us. So this is going to be great. OID for VC TypeScript and OpenID Federation TypeScript. All three of those links will take you directly to the GitHub for those projects, but also a quick little description of each one. In addition, we're all back to work. We had a great wallet interoperability SIG yesterday, and we're looking forward to the other SIGs and project meetings starting up again this week and next week with the new year. So thanks, Shar. That's it for me.
Yeah, awesome. Thanks for adding those in. Let's see. Under non-creds, they've been working on revocation scheme design that is based on Allosaur and cryptographic accumulators. They've also been discussing the revocation manager and working towards a non-creds BBS. For the indie contributors working group, we've been working on coordinating the Ubuntu 22.04 release. We've got folks in the community working on that, so just coordinating that work and where the updates will happen. That is going well. Let's see, in the Trust Over IP Foundation, I was not able to find a more recent all members meeting. correct me if I'm wrong and I'm just missing those notes. But as far as I can tell, October was the last one. In the governance stack working group, it looks like they're considering merging with the ecosystem Foundry working group, which I believe has been on hiatus for a little while. And then discussing nominees for the TRIP steering committee. In the technology stack working group, they have a bunch of different task forces, trust registry, trust spanning protocol. So lots going on in all of those. I won't go into too much detail, but there are links to all of those and their progress here if you're interested in digging in further. And then in concepts and terminology working group, they're working on the TRIP glossary v1 and diff synchronization. Let's see, any other TOIP updates anybody would like to give?
Yeah, I guess the big one is we're now fully under Linux, digital trust, and all the IP has moved under that as well. All the the legal matters under IP are now under fully under the Linux digital trust. That was the big thing.
Okay.
And we have an updated calendar starting 2025. So if folks are interested in joining any of those working groups, you should go to the updated calendar, which was updated for 2025.
Do you happen to have a link for that?
Oh, I could get it.
Okay,
Yep. I'll put it in
awesome.
the
Yeah.
chat. Yep.
Okay, then I'll put it on the page. Thank you. That's super helpful. All right, let's see. In the Decentralized Identity Foundation, in the DIDCOM spec working group, which meets on the first Monday of every month, they discussed the recent hackathon. They've also been discussing adding sessions to DIDCOM connections. They've been evaluating how DIDCOM could feed into or support the TOIP trust spanning protocol, and also looking at DID Web VH, new DID method, and how that relates to DIDCOM. In the DIDCOM users group, so there was a recent interopathon hackathon. The focus was testing DIDCOM v2 features. Some great discoveries were made, specifically around supported key types. So that was a success. In the DID Web VH working group, they've been working on it sounds like they've got a new version for the specification for publication, made changes related to pre-rotation and witness proofs. So that is going well. Let's see, IoT special interest group. I have not been aware of more recent meetings there. Does anybody know, Jim, am I remembering that you were involved in that group? Do you know if they've been meeting?
Yeah, I'm so glad. Yeah, Shard. We have not met for a while.
Okay.
Damien was running it from the diff perspective, and so it was a diff group. And then I know it merged over. I'd welcome a conversation about the possibility of volunteering to try and regenerate interest. We were making some nice progress in specific areas like porting indies over to Rust and a couple other things from the IoT perspective. So if we think there's interest out of here, I'd happy to have a group meeting to discuss it.
Yeah. Yeah, that's great to hear. Thank you for that update. Yeah, definitely want to hear if that group gets starts up again. So thank you. Let's
Yeah,
see.
certainly. And I'd add really quick too, I'm involved also with the Digital Twin Consortium and a focus on virtual human twins. And we've been talking about, medical devices and wearables and IoT from that perspective, and then how you secure data. So I think it's timely for visiting, what a VC infrastructure would look like for that. Thanks very much.
Right. Yeah, thank you. That's great to hear. All right, let's see. And then in the W3C standards group, their links for recent meetings. VC API did diff proof of age workshop that happened recently, and the CCG call. So on did traits. So recent calls if you're interested in those. So that was a super quick overview of some of the working groups in the community. Are there other announcements, other groups that anybody would like to bring to our attention? All right, and thank you for that link, Daniel, to the new TYP calendar. I will
Sure.
add that in. Awesome. Great. Well, with that, I will pass it over to you, Daniel.
Thank you. Okay, you should see my screen share now. So,
Yes, looks great.
excellent. Thanks again for the invitation to present DACL here today, the Digital Credentials Query Language. So let's start with a clarification. This is a DACL, and we're talking today about DCQL, or DACL as it's pronounced. This is a new query language for credentials that has been developed as part of the OpenID Foundation's OpenID for VP specification. So right now, this is just scoped to OpenID for VP, but there's nothing in principle keeping this from being used more widely. It's just that right now it happens to be a specification like a part of OpenID for VP. It's relatively recent, so we added it to VP 2 or 3 months ago. It is a part of the latest implementers draft that is to be released soon, and it may or may not replace presentation exchange in OpenID for VP. So as you may know, for those of you who are familiar with the development of OpenID for VP, there used to be no specific query language, like no query language designed for OpenID for VP in that specification, but it just said at some point, please use presentation exchange. And I get to the reason why DACL was developed in a minute, but basically the idea is that we developed DACL. We want to figure out whether it fulfills all the use cases and all the requirements. And then it may replace presentation exchange over time in OpenID for VP. Right now, there's a clause somewhere saying that if you use OpenID for VP over the Digital Credentials API, the browser API, then you have to use DACL. Because a lot of the requirements we had were, or concerns we saw with presentation exchange were in the context of the browser API, the Digital Credentials API. And just as presentation exchange, DACL is a JSON-based syntax for requesting credential presentations. No big surprises there. So if you're familiar with presentation exchange, you will see that some of the structures look similar. Yeah, so basically a similar approach. And it's mostly credential format agnostic. So most of the things you see in there, like 98%, I would say, are really credential format agnostic. Some specific things depend on a certain credential format. So right now in the spec, we talk about JOT-based formats like SDJOT. We talk about binary formats like MDoc. This is more generally applicable. This is just what we have to find right now. So why did we do that? Why did we decide, or the working group decide, to develop a new query language? is it just not invented here syndrome? I don't think it is. I hope it's not. There were very concrete concerns about the complexity of presentation exchange in many different ways. And one of the main reasons for Dackel was that when you so it came from the browser and operating system vendors. When you send requests over the digital credentials API, you want to do that in a way that the API itself can understand the request and can check the request, so that you can ensure that the request is correct syntactically and makes sense content-wise already on the API level. So ideally, the format should be simple enough, and there should be exactly one way to express certain things, like a selection of credentials, instead of many ways. And presentation exchange does provide many ways to do the same thing. And that was one of the concerns, and the general complexity as well. And we saw that presentation exchange does offer a lot of features that are not really required for most use cases. To provide you a little bit more background on the complexity of presentation exchange, it's not only on the syntax itself, but also on the implementation. So if you look at presentation exchange, it does require you to understand JSON path. So both a wallet and a verifier need to understand JSON path. JSON path is great, but if you have to implement all of it, it's a lot of code. You need to have a parser that goes through strings and disassembles them and evaluates them. You have to implement a lot of different functions and predicates and regular expressions as well. I list that separately here because regular expressions also always introduce potentials for security flaws, for performance problems. And yeah, so you do have to implement all of that. And you have to implement it in a way that is secure. So all the input, speaking as a wallet, your request, your presentation exchange request comes potentially from an attacker. So you have to implement all of that securely. And that is a real challenge. And also similar concerns with JSON schema filters, which are part of presentation exchange. So you have to implement all those filters. And again, regular expressions show up. Yeah. So that's just a lot of complexity. And that's really hard to get right and to implement securely. And then there's the usage complexity as well. So presentation exchange gives you all these features, but not all of them are needed, especially in the context of OpenID4VP, which does bring its own mechanisms for certain features. But for example, there's this presentation submission data structure. That is just not required in the context of OpenID4VP. So you can just send the presentation over. You don't need that presentation submission data structure. And generally, PE does have a lot of optionality in various places. One of the approaches that was actually considered in the DCP working group that is specifying OpenID4VP was to say, let's take presentation exchange and define a minimal feature set so that implementers can implement only that, and that users know that they can or should focus on those parts. But still, that was a lot of complexity, and that was also very hard to get right. So that was an approach that was considered, but then not pursued. And speaking of the implementers, both the verifiers or developers for verifiers and the wallets, they have to deal with a lot of potential variation in requests. So how do you exactly request a claim? How do you form a path And how do you check a claim's value against the string, for example? PE gives you a lot of tools for all of these things. And for example, with the claims value checking, you can check that against like using the pattern filter, the const filter, or the enum filter. And we have experienced wallets that do implement only a part of this, and then verifiers that happen to use the other part. So in the German Funke wallet competition, we had a wallet that, we told wallets, please support checking for checking a claims value as a kind of minimal thing to do to support. And then some wallets implemented it using const and some using enum. And of course, then the verifiers broke. So that just goes to show the kind of variation you can have in those requests and all of those things you have to implement as a wallet. And then we also found out that some features are not supported by presentation exchange. For example, when you have an SD draw, then you can have a type which is expressed as a VCT value in SD draw. And those VCT values, they are they form a tree. So a VCT value or type can have a another type that it extends. And when you want to request a credential, you want to say, I want to have a credential of that VCT or of any type that extends this VCT. You can't really express that in PE. This would have been one of those things we could have defined additionally on top of PE, but it again would have caused a lot of complexity and yeah, just adding stuff to PE that was not there. It's not a nice thing to do for an implementer. They have to go and take a PE library and then add some stuff on top of it. So these were the reasons why we said, yeah, PE is nice and it helped us to get to this point, but now we need to do something else. And that was when we came up with Dackel. So how does it work? What does it look like? Well, it's relatively simple for the simple cases. That was one of the design goals. Here's an authorization request, an OpenID for VP request. And you can see the various parameters here. And the last one is DCQL query, Dackel query. This is just a JSON object that you can send, and that contains the whole request. Very simple. What does the request look like? Here's a very simple example. We have the credential or credentials array. In this array, you can define a request for each credential that you want to have. You define some ID. You say which format you expect, for example, VC plus SD draw. This should probably be updated to DC plus SD draw, as it's now called. There's meta information that you can request. For example, here we say that it must be one of those VCT values or a type extending that VCT value. So this is where this logic comes into play. And then we have an array of claims that are requested. And here you just say, okay, so for each claim, you define the path. The path is intentionally not a JSON path or JSON pointer. Instead, it is an array where you just say the first part, so it's just evaluated from the left to right. So here we say it's just last name, top level element, last name, top level element, first name. And here it's top level element address. And within address, we only want to have the street address. And hopefully your selective disclosure supports that. And then you can return the street address here. The reason why we chose this syntax, this array syntax for the path. So it's essentially what I said before. JSON path and JSON pointer both introduce a lot of complexity. For both of them, you have to pass the pointers because they are encoded as strings. Here it's much more simple. You can just use your regular JSON parser to process the whole object, and then you get this array, and you don't have to do string processing. You can just go through the array and follow the data structure in the credential, select the element, and off you go. So it's very simple to evaluate. It's very simple to describe for us. The description of those path elements, it's, I don't know, half a page, maybe 3/4 of a page. So it's a very simple algorithm to evaluate those. So if you send that request, the expectation would be that you get a credential, and in this case, in a VC plus SDJ format that extends this type, and you get at least these three claims: last name, first name, and address, street address. Very simple. And in the response, it will be returned under the key my credential. It's just an identifier for you to find the response to the request. We can do the same with mdoc. So this is an ISO mdoc credential request. Here we have a different format identifier, obviously. We have a doc type value instead of the VCT, because that's how you do it in mdoc. And then you define the claims, and here the path element. And this is one of the places, the few places where this is not credential format agnostic, because in ISO mdoc credentials, we have a namespace and then a claim name. So we don't have a path because they don't have these nested JSON structures or whatever. They have a namespace and a path. So we use those here in path, namespace, claim name, namespace, claim name. So here we would get vehicle holder and first name as the two claims in the response. Yeah. You can also request more than one credential at the same time if you want. So here's an example showing you where you would request a PID. For those not familiar with the European wallet, this would be person identification data. So you would ask for some kind of identity credential. So this would be one request for a credential. And then there would be a second one where we ask for an mdoc, maybe a vehicle registration. So you would just list those credential requests one below the other. Very simple. You can also do more complex requests. For example, if you want to say, I want to have claim A or claim B. You could also say, I want to have this set of claims or that set of claims. This is an example for that. We request some credential, which here is called PID. Doesn't matter. We have a couple of claims, and each of those claims, again, is listed with a path: last name, postal code, locality, region, date of birth. But we have given those claim requests, or whatever you want to call it, we have given those IDs, X, A1, A2, B, and Y. And now we can, with those IDs, we can say, here's a definition of claim sets that I, as the verifier, am willing to accept. So you can say the first claim set that I'm willing to accept would be X and A1 and A2 and Y. So if you can deliver all those four, please do. And the alternative, if a claim is not contained in the credential, would be to say, I want to have X and B and Y. So in this way, you can define various sets of claims fulfilling the same use case. For example, if you have in a European context, for example, we will have identity credentials that are slightly different across the European Union because member states use different methods to enroll those credentials, to create the credentials, and they have different sets of data available. Some of them, for example, might have an address field, some of them don't. Or within the address field, some of them might have a region claim and some of them might not have that. So this allows you to formulate requests for those claims, sets of claims. The important thing here is, and that was a point where we really had to work on like a long time. The important point here is that this is not about user choice, not at this level at least. Here it's about the wallet selecting one of those options, and the rule that we have right now in the text says the wallet must select the first available option. So in the request, if you get this request and you have a request for X, A1, A2, and Y, and this is in the credential that you have in your wallet, then this is what the user will then be asked to consent to, and which will then be sent. But the user will not be asked whether they want to release X, A1, A2, and Y, or X and B and Y, because the assumption here is that this is just a technical mechanism to allow for variations in the credential data. It's not about giving the user the choice to use, I don't know, the digital credential for their passport or the digital credential for their driver's license if both of them are available. That's at a different level. That is actually what we have here in this in the second example, A or B credential matching, because just as on the level of the claims, we can do a similar thing on the credential level. So here we have various requests for credentials. We have one that is called, that has the ID PID, some request following. Then we have some other thing that's here just called other PID part 1 and other PID part 2, and a nice to have credential. And then we can say, here are credential sets I am willing to accept. And just as before, we can have a list of credential sets that can be accepted by the verifier, but this time we also have a purpose field. So the verifier has to say, this is the purpose for which I need those credentials, for example, identification. And here are the options I am willing to accept, which could be, in this example, just the PID credential, or a PID credential that, for whatever reason, consists of 2 parts. So the user will see the verifier wants to have an identification from you, and maybe we have a PID available, or those other 2 credentials. Now, you as a user can choose which one to present. And for a different purpose, we here have a request called show your rewards card. This is not required. So the user will see, okay, this is completely optional. You can do the identification thing without showing your rewards card. But if you want to send the rewards card, you have to fulfill one of those options, which in this case would be the nice to have credential here. So this is where the user choice happens, and it only happens at this one level. We don't have multiple levels of user choice, which can be extremely hard to implement in a wallet. Yeah. We also provide a mechanism for simple value matching. So if you have a credential and you already know that you are, as a verifier, only interested in credentials where the last name is Doe, or where the postal code is within a certain value range, then you can do that. You can just say that in your request. This will most likely be considered a best effort thing to do for the wallet. Not all wallets have access to the claim values ahead of time before the user has consented to the release. And value matching is hard, as usual, especially if you have languages with diacritics and similar things where the value matching can just maybe not be so clear. Then users might have a choice sending a credential anyway that might technically not fulfill the value matching, but that makes sense in that in that context. So it will always be up to the verifier to ensure that they receive valid data, but this is a mechanism to ensure that the verifier can at least try to avoid receiving data that is not useful for the particular use case. And We're also considering more advanced features where you can say, where you can do complex value matching. For example, that you want to have the postal code within an address start with a certain value, or an email address that ends with @domain.com. Where they are not in the spec right now, but we're considering to add that later on. Yeah. And also ZKP features where you can say, for example, I want to request a birthday claim, but if you support ZKP, I'm not really interested in the birthday. I just want to know whether the user is above 21. And such things. We have ideas how to do it. It's just not in the spec yet because agreeing on this part was a lot of work already. And we wanted to see whether those parts work as intended before we go the next step. Okay, just briefly, what does the response look like? Very simple. There's a VP token, which was then OpenID for VP before. And the VP token, if you send a Dactyl query, will look slightly different to what it looked before. If you send a Dactyl query, it will just be a simple object where for each of those IDs in the credentials that you requested, you will get a credential. And if it's SDJOT, for example, you will just get this presentation of that credential as a string. For other formats, it can also be, for example, a JSON object here. So what's missing from this? As I already said, more complex value matching is one of the goals that has been discussed. Then also ZKP queries. There's also some other ideas floating around. For example, there used to be an attribute called intent to retain, where you can say, I want to, or I do intend to store that data that you're sending me. This is under discussion to add that back into Dactyl. And for example, another thing that was mentioned in discussions was a feature to say, I don't really need key binding for this credential. I'm just happy to learn that that credential exists. I'm not interested to learn whether this credential was bound to your device or your identity or whatever the key binding means in a concrete context. So what's next for us? Well, the most important thing right now is to gather implementation experience. So I'm very happy to see one Dactyl implementation going to Open Wallet Foundation. We have the implementers draft out for OpenID for VP soon, where we actually define those things. And well, we are looking for feedback from implementers and then hopefully to fix anything that comes up. We do have a couple of things open in the working group, in the issue tracker, that we'll need to work on, some smaller changes in the spec, but so far, nothing too big. Another big point will be to decide on the fate of a presentation exchange now that we have a Dactyl as well. It's a relatively complex solution space, whether we want everybody to support both, probably not. Whether we want to say wallets may support one or the other, and how verifiers then are supposed to know whether the wallet supports one or the other. So that's still a bit under discussion. And then, of course, add any features we identify as missing, anything that comes up where people say that they really need it and have a good use case for it. So my ask to you would be, probably you already, after listening to this, already have a few thoughts on this. So please contribute in the Digital Credential Protocols Working Group at the OpenID Foundation. There are weekly calls, and there's also the GitHub repository, openid/openid4vp, where you can go and look through the issue tracker and the pull requests and everything else that we have. And if you want to discuss in person, a lot of the members of that working group are going to be at the OAuth security workshop in February, last week of February, in Reykjavik in Iceland. That would be a good opportunity to talk in person. That's all I had. Thank you very much. I think we might have an opportunity to answer some questions.
Thank you so much, Daniel. That was awesome. Super interesting. What questions do people have for Daniel? I had one question. Oh, go ahead. Go ahead, Daniel Buckenheimer.
No, I was saying still gonna say still absorbing. This is great stuff, but still no questions yet. But still soaking it in.
Thanks.
Yeah, same. I'm looking back through my notes. I had a question. So for the simple value matching, did you say that in this case, the verifier has to already have access to the set of claims that it's wanting to match, so that it can evaluate whether or not to fulfill the presentation?
The wallet has to. So it's an ask by the verifier to say, if you return anything, please ensure that it has this value in last name, for example. So the wallet, as the one providing the response, has to know those values in the moment it evaluates the request. And most wallets do. So most wallets just know the credential data they are handling. Some wallets don't. There are architectures where the wallet is, or parts of the wallet, the credential handling is implemented in a secure area somewhere. And the component evaluating the request knows which claims are there, but doesn't know their value necessarily. In that case, you cannot do the value matching, at least not easily. You would have to kind of forward that to that component, but that can be hard under certain circumstances. For most wallets, it will not be a problem.
Okay, interesting. I wonder how that works with multiple wallets on the same device.
That's another
like
great
if
question. Yeah.
Mhm.
Exactly. If you have multiple wallets, and maybe in your response, you even want to combine responses from multiple wallets. That's challenging and not completely solved yet.
Okay, interesting. Thank you. Also on simple value matching, the ZKP aspect that you mentioned, specifically in the age verification use case. So would this require that you have an over 21, for example, credential? Like, does that credential need to be present, or is there a way that the birth date itself could be checked to generate a response that indicates whether or not the presentation can be fulfilled?
That does depend on the credential format. So if you have something like SD-JWT, salt hash-based approach, where you can just selectively release stuff or not release stuff, then you would have to have an attribute saying user is above 21, and then you can release that. But if you have a proper ZKP enabled format, you can also derive those proofs, and you can say, okay, this birth date, also I have the birth date in the credential, but from it I can derive a proof that the user is actually above 21 without releasing the birth date. But it does depend on the credential format. So
Right.
It's
Yeah.
not, so it's not universally applicable to SD-JWT, for example.
Oh, interesting. So it's
Yeah, I was going to say, like the MDL standard using MDocs, you have to have static predicates, as they're called.
Yeah.
In other words, the issuer has to issue an over 21 predicate because they don't have dynamic predicates. They can't create that proof on the fly with MDL, with the MDL spec. You have to have an MDoc that's cryptographically signed by the issuer saying is over 18, is over 21, is over 65. Right.
Exactly.
Okay,
Yeah.
interesting.
And that kind of thing would be supported by DACL today. But since the gold standard is a proper ZKP enabled format, we also want to look ahead and enable DACL to support those use cases as well, where you can dynamically derive that proof. Yeah.
Oh, okay, that makes sense. So it's more about that the wallet needs to know what the credential, what the attribute value is, and it doesn't matter so much whether it's a static attribute or a derived dynamic predicate.
So right now, so the idea is there can be both. Like even within one ecosystem, you can have formats like stjot where everything's static, or mdoc where everything's static. Everything has to be signed ahead of time by the issuer, as Daniel said. For those, you can just use DACL. You can just ask for the predicate, is the user above 21? And because that's just a regular claim in the credential. And then, but hopefully, at some point in the future, we will have credential formats that do ZKP, and we have DACL extended so that we can ask a ZKP or a wallet that has a ZKP enabled credential to derive something dynamically. So the wallet has the credential, and we as a verifier can ask the wallet, is the user above 13, 14, 15, 16, 17, and so on, dynamically derived without all of those attributes having to be present in the credential. And we would need to extend DACL in a way that we can express those things, that we can say,
Okay.
I'm asking for the birth date, but really I'm not asking for the birth date itself. I want to have a proof that the user is above, say, 13. Yeah, but that's future. That's not.
Oh, okay, I see. I see. Thank you. Super interesting.
Any other questions?
Let's see. I was also wondering, I know you mentioned this, but how DACL replaces the need for JSON path?
Yeah, I don't have an example for presentation exchange here on my slides, but it's essentially, let me see. It's essentially this part here. In the credentials, you have arbitrarily complex data structures. For example, here we have we assume a credential that has an address element, and within address it has street address, so it's a nested claim. There can be much more complex examples where, for example, if you have if you graduate from a university and you get a credential with all your courses and everything in it, then it can be extremely complex. So you can have courses, and you have grades, and you have, I don't know, whatever. So it can be extremely complex. So you have to be able to express which claim of those you want. So these are complex data structures. You have to be able to point into the data structures. And in presentation exchange, JSON path was used to do that. And with JSON path, you have one long string that in this example would be, I think, $$ $sign dot address dot street address. using a special syntax just for this kind of pointer. And this is a simple example. So in JSON path, you can do very complex things. You can, for example, say, I want to have of all the, I don't know, of all the courses that this user has in this credential, I want to have one where the grade is below a certain value, or I don't know. You can do very, very complex expressions, all crammed into one string. And there's even a possibility to, it's not intended, but in many implementations, to execute JavaScript within one of those expressions. And that's extremely complex to evaluate. And therefore we said, we cannot use that. We don't want to use that. But instead we just say, let's just provide an array of the pointer elements, so to say, so a very explicit way to say, what does a path look like? So here we just say, okay, the first element is address. You go to the address element in the credential, and then you search for street address within that point in the credential. So you can evaluate this much more easily and more securely, and yeah, it's much much easier to implement this than JSON path.
Right.
Similar things.
Right. Okay. Cool. Thank you for revisiting that. Are there other questions for Daniel?
That does not seem to be the case.
If you do have questions, we are going to post the recording of this session. It's going to be on the LFDT YouTube, but I'm also going to post it to Open Wallet Foundation Discord as well as the LFTD Discord, so we can keep the conversation going in whichever of those or all those places that you currently hang out in. So we don't. This was a great presentation. Thank you, Daniel. But also this is the start of something. Not we're really just getting this engine going. So pretty excited.
Yeah. Thanks for the invitation again.
Okay.
And please also feel free to reach out via email or LinkedIn or whatever if you have any questions around this.
Yeah, absolutely. Thank you so much for joining us, Daniel, and for your presentation. This was great.
Thank you.
And thanks everybody else for joining. Have a great rest of your day. Thank you.
Thank you, Shara. Thank you, Daniel.
Thank you.
Thank you, Tim. I'm going to pause the recording and